Hello viewers, welcome to Group 12 presentation on the fan-coil units. Let's get started. We start with some fan-coil unit basics. A fan-coil unit works by using a fan to move air through a heating or cooling coil to condition the air in a space. In its simplest form, a fan-coil unit consists of a fan and a coil. Taking each major component one after the other, we first talk about the fan. The fan is used to circulate air through the fan-coil unit and the conditioned space. The fan sucks air out of the room through the fan-coil unit and blows it back to the room. Next is the coil. The coil is used to heat or cool the air as it passes through the fan-coil unit. In commercial buildings, the coil is usually connected to a hot water or chilled water system. This is an image of a fan-coil unit, a typical fan-coil unit. So air enters the fan-coil unit from this part. It passes through the filter, which filters out all debris and particles from the air. It then passes through the coil. The coil can be a heating or a cooling coil. Here it's a heating coil. So the air that passes through it gets heated, and then the fan blows it back into the surrounding space. The key defining factor of a fan-coil unit is that it only recirculates air in a given space. If the unit uses its fan to bring in any outside air, then the unit is technically not a fan-coil unit. It's an air handler. Most fan-coil units have an air filter as well. The air filter is used to filter particulates out of the air before they enter the fan-coil unit. The air filter helps protect the fan-coil unit's internal components from dust and also cleans the air in the conditioned space. Types of a fan-coil unit. Every fan-coil unit can be classified into two general types based on the location of its fan. First is the blow-through fan. A blow-through fan-coil unit's fan is upstream, behind the coil. The fan blows air through the heat exchanging coil. Next is the draw-through fan coil unit. A draw-through fan coil unit's fan is downstream, that is, in front of the coil. The fan sucks air through the heat exchanging coil. Let's look at some differences between blow-through and draw-through fans. For the blow-through fan coil units, the fan is located before the cooling or heating coil, whereas in the draw-through fan coil unit, the fan is located after the cooling or heating coil. Next difference is the air is blown through the coil by the fan in the blow-through fan coil unit, whereas in the draw-through fan coil unit, air is drawn through the coil by the fan. In the blow-through fan coil unit, higher turbulence across the coil, which can result in uneven temperatures on the coil surface exist, whereas in the draw-through fan coil unit, more and even airflow across the coil, leading to consistent temperatures on the coil surface exists. In the blow-through fan coil units, there is a requirement of a longer plenum or space between the fan and the coil to ensure proper airflow, whereas in the draw-through fan coil units, no additional plenum length is needed, making it more compact. In the blow-through fan coil units, there's a higher chance of moisture and carryover, which can affect the fan and system efficiency, whereas in the draw-through fan coil units, there's a lower chance of moisture carryover as the fan is positioned right after the coil. Another way of classifying fan-coil unit can be based on what flows through its coil. If refrigerant flows through the coil, then it's considered a direct expansion fan-coil unit. And if water flows through the coil, then it's considered a hydronic fan-coil unit. In a direct expansion fan-coil unit, the coil serves as the evaporator or condenser in the refrigeration cycle. An example of a direct expansion fan-coil unit is the indoor unit for a split system air conditioner. In a hydronic fan-coil unit, chilled water or hot water flows through the coil to cool or heat the space. Hydronic fan-coil units are usually only used in large buildings with centralized heating and cooling systems. We'll further classify the types of hydronic fan-coil units. When it comes to hydronic fan-coil units, there are two main types. The first one is a 4-pipe fan-coil unit, and the next is a 2-pipe fan-coil unit. Each will be explained in details in the next chapters. How a 4-pipe fan-coil unit works. A 4-pipe fan-coil unit has two coils, a cooling coil and a heating coil. Each coil is connected to two pipes, one pipe for the water supply and another pipe for water return. So as you can see, we have a cooling coil and the heating coil, with each connected to a water supply. So the cooling coil is connected to a chilled water supply and the heating coil is connected to a hot water supply. So air enters through the fan coil here and it passes through the air filter where it is filtered. This then passes through the cooling coil to outside. And if it needs to be heated, it will pass through the hot water coil where it will be heated and pass to the surroundings. Both cooling and heating coils have their own individual valves. So there are separate cooling and heating valves. The cooling valve opens if cooling is required in the space. The heating valve opens if heating is required in the space. Next is a 2-pipe fan-coil unit, and here we talk about how it works. A 2-pipe fan-coil unit has one coil connected to two pipes. One pipe is for the water supply and the other is for water return. Chilled water or hot water flows through the coil depending on whether cooling or heating is required in the building. The flow through the coil is controlled by a valve on one of the pipes. The valve opens and closes depending on the heating or cooling demand in the space. How does a 2-pipe fan-coil unit know if it has chilled water or hot water flowing through its pipes? Well, this is a function of a part called the changeover sensor. The purpose of the changeover sensor is to detect whether chilled water or hot water is flowing through the pipe. When the changeover sensor detects hot water flowing through the pipe, the fan-coil unit control board goes into heating mode and opens the valve if heating is required in the space. When the changeover sensor detects chilled water flowing through the pipe, the fan-coil unit control board goes into the cooling mode and opens the valve if cooling is required in the space.